Okay, today we will start lecture 5. We'll talk about modeling of digital control systems. In last class, we looked at what we call it the pulse transfer function, and we were able to find the pulse transfer function of a system in the presence of a sampler. As you can see, for example, in the bottom of this figure here, I have two cascaded blocks. However, each of them is preceded by a sampler, as you can see here. So if I want to find the pulse transfer function, and the pulse transfer function means it is the relationship between the output and the input in a discrete system. So if I want to find the pulse transfer function for this system, then I will start as this. For example, as you can see, there's a sampler here, and you have y star, which is actually coming from the sampled y of s here. So if I want, for example, to find what's the pulse transfer function for this system, I will write y of s, which is here. It is coming from this signal, the u star of s times h of s. So it is u star of s. U star means it is sample signal, h of s. So for example, here I can get y of s equal u star v h of s. Now if I want to get y star, then y star, what is it? y star of s تساوي u star of s. طبعا بتاخد لكل هذا اللي هو Laplace transform, start Laplace transform. كونه high already in that form, so h of s star will be. And straight away I can from here find the z transform. However, this is not yet written as output and input. This is output, as you can see, y star of s, but the input is x of s. So I have to write this in terms of y of s and x of s. So let's continue then. Y star of s, what is it actually? It is, u star of s, what is it? It's coming from here. So u star of s, it is u of s itself, but taking the starred Laplace transform due to the sampler here. So I can write u, for example, of s اللي هي high signal. شو هي؟ عبارة عن x star of s. هي داخل هون x star of s مضروب في g of s. So this is u of s. But what I want u star of s. So I can take the asterisk or the star for all of this. So I can get u star of s equals to x star of s, g of s star. Now this is u star of s written in terms of input and g of s. I can substitute for it here. So you can get y star of s equals to x star of s في g of s برضو star في h of s star. Therefore, the z transform for this, I can write, you remember we said that the z transform for a sampled discrete signal, it's obtained as the z transform. I mean, if I want to find the z transform for this, so I can just do the z transform by replacing the z equal to e to power st, if you remember that. So I can write this straight away, y of z equals to x of z, g of z في h of z. يعني معنى آخر, if I want to write y of z, the output here, I can write it as the z transform of this, the z transform of this, multiplied by the z transform of the input. لاحظ هاي الشغلة مهمة. On the other hand, إذا السيستم لاحظ هون مثلا زي هذا السيستم ما في عندي سامبلر in between, ما في. شو بفرق هذا عن هذا السيستم. خلينا نشوف. هلا هون نفس المبدأ y of s I can write it y of s من الاوتبوت هون it equals اللي هو الانبوت u of s في لاحظ الفرق هون في h of s. الانبوت signal ل h of s is not sampled signal. It is not a sampled signal. Okay, now u of s, what is it? u of s, what is it? It is actually x star of s في g of s. As you can see it, it's x star of s في g of s. So لاحظ u of s, it is not sampled signal. It is not like in the case before here. It is sampled. It's discrete form here, converted discrete form. So here I have u of s equal to x star g of s, and I can substitute this into this equation to obtain y of s equals to x star g of s في h of s. So now if I want to do the starred Laplace transform for this, notice I have to multiply first g times h, then I can do the z transform. بمعنى آخر I can write y of s star equal x star of s طبعا في gh of s. I multiply first these two functions, then I will take the starred Laplace transform, which will lead me to من star to z x of z في gh of z. بضرب g في h أول وبعدين بعمل لهم z transform. فهذا x of z في gh. فالبulse transfer function of the system can be written as y of z over x of z equal to gh of z. أو اللي هو زي ما كتبنا y of z equal to x of z gh of z. Compare this result with the previous result اللي هي وين كتبناها هاي x of z g of z h of z. I said the z transform of this times this times this. Here the z transform of this times the z transform of this times this, and you have to multiply these two first, then find the z transform for it to find y of z. Now we have different configurations where you can simplify those configurations and write the z transform. Now, writing the z transform or the transfer function, for example, the pulse transfer function for such a system, it depends on the location of the sampler. Maybe you will have a sampler here, maybe a sampler here as well, maybe a sampler here, so maybe you have three samplers at the same time, or maybe you have one sampler here, maybe you don't have it here. So we will look at all these combinations and try to write the z transform or the pulse transfer function of such systems. Let us start with these. Okay, let us start with this. Let us start with this. I will copy it. I'll copy this one. And let us work on it here. Now this is, as you learned maybe in automatic control, this is a feedback control system. However, this time I have a sampler here. يعني معنى أخبطل هذا continuous time signal. هذا yes, continuous analog signals it could be, but here they are sampled and there's a discrete signal that goes into G of S. So let's write the pulse transfer function if there is a pulse transfer function. We will write the pulse transfer function for this, which means that y of z over r of z, if there is, because sometimes you cannot split the input from the rest of the system. So you cannot write a pulse transfer function, you can write an output equation. So let's write what's y of z. First, y of s, as you can see it here, this y of s, it is coming from E star of s times g of s, as you can see it. E star times g of s equal y of s. Now, at the same time, E of s, this signal, is coming from, again, it is y of s في h. y of s, it is E star g of s مطروح من r of s. معنى آخر E of s هاي هي عبارة عن r of s, as you can see it, r of s minus. شباب معاي انتوا؟ في حدا عنده سؤال؟ بلاش اظني احكي انا هيك
معك دكتور معك.
طيب، هي y سوري مرة تانية E of s اللي هي هاي السيجنال equal r of s minus what comes from here. What comes from here, it is E star gs في hs. So it is E star of s في g of s اللي هي يعني y في h في h of s. This is E of s, as you can see it. Now if I take the start مرة تانية, r of s minus E star of s في g of s في h of s اللي هي هذه السيجنال مضروبة في h of s اللي هي E star gs h of s, هذا كله مطروح من r بيعطيني E of s. So if I take the standard Laplace transform for both sides of this equation, this is E star of s equals to, you have to take the standard Laplace transform of all of this term minus E star of s g of s h of s. لاحظ هلا الستار Laplace transform E star of s, for this it is r of s star, linearity property. Now if you look at this term, as you can see, this term already is starred, it's discrete system or discrete signal. Now these two, if I want to find the starred Laplace transform for them, I have to multiply them first. بمعنى آخر, this term is already starred, so it is E starred of s, and these two اللي هم GH of s, I will find for them the starred Laplace transform. So E star, then I can combine it or can get it from here and move it to the side. I can write E star of s زائد E star of s في, لاحظ GH of s, كل هذا الترم starred يعني بضربهم وبعدين بطلع الستارد Laplace transform for them. This equals to r star of s. Now take E of s common from here, so you can get E star of s equals to r star of s over 1 plus GH of s start. Okay, now here I need to get again output and input relationship. This is the output, so I will go back and write y of s equal to E star of s في g of s. If I take now the discrete form of this, it is y star of s equals to E star, لاحظ هذا discrete signal multiplied by this, so it's going to be E star في g of s star. So if I replace E star from this equation, you can get y star of s equals to r star of s g of s star over 1 plus g h of s star. هذا معناه انه y of z equals to, لاحظ G of Z, R of Z. لاحظ الانبوت is written as a Z transform separately from G, so I can write a pulse transfer function. يعني شو يعني؟ يعني بقدر أقيم R of Z وأحطها هون وأكتب pulse transfer function over 1 plus GH of Z. لاحظ GH of Z. You multiply G times H يعني G high times H وبعدين بتاخذ الزي ترانسفورم لها. في البسط عندي G of Z في R of Z، هذا نتيجة السامبل اللي كان موجود هون. ف Y of Z مرة ثانية، so I can write from this, I can write in this format Y of Z over R of Z. لاحظ I can pull out R of Z separate from this, and here I can write a pulse transfer function. It's equal G of Z over 1 plus GH of Z. So this is the pulse transfer function for the system. Now let's examine other systems. Let's examine this system. For example, لاحظ هلا هذا، خليني اخذ هذا السيستم اللي هون. And if you compare it with our، هلا بنحط هذا اول شيء هون وبنقارن. هلا بتلاحظ هون في هذا السيستم اللي اشتغلنا فيه مبدئيا، في عندي سامبلة واحد here at the error signal, and look the pulse transfer function how it came out. Y of Z over R of Z equals G of Z. You can split that signal or get it as discrete form on its own over 1 plus the feedback اللي هو صار G في H وكله بتاخد له Z transform. طيب قارن هذا السيستم with one sampler here at the error signal with our new system. Here we have another sampler before the output or the feedback. يعني في عندي هون قبل ما اخذ كان اول في عندي feedback من هون. السيستم اللي قبل شوي شفناه كان في feedback من هون. You are feeding this signal straight away to H. Here no, we have a sampler and then we have the feedback loop. Let us see the difference between this system and the previous system. Again, from here I can write Y of S اللي هو الأوتبوت هذا يساوي E star. في حدا عنده سؤال شباب؟ E star of S في G of S.
كله تمام.
Are we good?
Okay.
Okay. Now, if you observe, there's a sampler here, and I have E star times G of S equal to Y of S. Now, there's another sampler here. So the signal that comes from this, if you look at it, which is Y، يعني هي حتكون Y star of S اللي هي جاي من هون وفيدباك here. لاحظ Y star of S اللي جاي هون اللي هي حتكون عبارة عن E star of S في G of S star. هاي السيجنال اللي هي داخلة على هذا البلوك H of S. طيب لو جينا نكتب مرة ثانية ايش الايرور سيجنال هون، ف E of S اللي هي هاي عبارة عن زي ما حكينا هاي السيجنال اللي هي داخلة Y star of S في H of S، فهي E star of S، أو خليني أكتبها بالعكس، هون في عندي R E of S equal to R of S minus اللي جاي من هون اللي هو E star of S في G of S star. لاحظ هذا كله مضروب في H of S. So if I want to get now E star of S, I can take the asterisk for all of this. So E of S star equals to R of S اللي هو star Z Laplace transform. لاحظ هذا star already discrete، هذا discrete, so I have to find the discrete format of this. This is E star of S, G of S star, H of S star, and you rearrange the equation, you get E star of S equals to R of S starred over 1 plus G لاحظ of S starred on its own H of S starred. So if you plug this into this equation you get Y starred of S equals to اللي هو G of S starred 1 over G of S starred H of S starred مضروب في R of S starred, and that can give you the Z transform as Y of Z equal G of Z في R of Z. لاحظ I can split the input, separate the input from the block G, and here as well G and H are separated. G of Z لاحظ H of Z. So for this system, the pulse transfer function, if you want to find it, it is the Z transform of the input times the Z transform of the forward gain over 1 plus the Z transform of the forward gain times the Z transform of the feedback. لاحظ النتيجة هاي يعني Y value of Z. I can write a pulse transfer function in this form because there's a term of R of Z here equal G of Z over 1 plus G of Z في H of Z. Compare this with the previous one. It was G
هذول
of
مع
Z.
بعض.
Exactly. You combine these two and you find the Z transform here. Here, no, you find the Z transform for this and the Z transform for this separately, and then you put the pulse transfer function in this format. Okay, so let us take another example. Let me take one more. Can you verify these? I already actually derived this pulse transfer function for all of these configurations. Can you verify it or do it on your own? Let me take this one. Okay. Let me take this one. And I'll leave the rest for you to verify it. Now again, this is the output لاحظ Y of S and is fed back through this path H of S back here. So let's first write Y of S. Y of S, what is it? What comes into this block? صحيح? Let me call this, if I call this U, let me call this U star then of S. صح؟ مظبوط? This is U of S, then this is U star of S. So Y of S equals to U star of S في G2 of S. Now, from here as well, I can write U of S. نيجي هون. U of S اللي هي السيجنال اللي أنا كتبتها هون تساوي E of S في لاحظ E of S في G1 of S.
هسه
Now let me
طلعت الاي
write
اوف اس.
بدأ
والبعدها بنطلع الاي اوف اس كمان.
هلا E of S بدنا نطلعها هي ايش تساوي؟ U
الواي اوف
star
اس في الاتش اوف اس.
U star مظبوط يا بدر U star of S في G2 of S مظبوط في سوري نسينا نحكي يلا ماشي مرة ثانية هي عبارة عن R of S هاي السيجنال minus what comes from here. So if I want to find it in terms of let me find it in terms of of E of S. So R of S minus what comes here, it is U star of S في G2 of S في H of S. مظبوط هذا كله جاي من هون U star في G في 2 في H هذا مطروح كله من R of S بيعطيني E of S. So هذا E of S مرة تانية U star G2H في minus r of s اللي هي هذه بيعطيني e of s. مظبوط. هلا لاحظ العلاقة بين e of s و u of s هي ايش؟ g1 of s. I can write then from here u of s equals to محل e of s اللي هو ايش؟ r of s صح؟ minus u star of s g2 of s h of s مضروب كله هذا في ايش يا بدر؟ هذا هذا e عوضنا محلها من هون في
G1.
g1 of s صحيح؟
صحيح.
if you write u of s you can write as r of s في g1 of s minus u star g2 of s g1 of s h of s دخلناها عليهم. Take the star Laplace transform for this, so it is u star of s equals to the star of all of this. Now
على أعملهم ضرب أول شيء.
هلا بالضبط. هلا هذا يا بدر الترم r of s في g1 of s فحيكون r g1 of s كله باخذ الستار، يعني بضربهم بعدين باخذ لهم الستار لابلاس ترانسفورم. تمام. minus if you look at this is already star, so I can exclude it out. This is u star لأنه already هو star discrete. Now I have to find the discrete form of all of this اللي هو g1 بضربها في g2 في h of s وبعدين بطلع لهذا ايش؟ الستار لابلاس ترانسفورم. وصلت؟ So I can now rearrange this as u star of s equals to بنقل هذا لهون وبطلع عامل مشترك إلى آخره، حيطلع عندي r في g1 of s star هذا كله هذا الترم على 1 زائد g1 g2 h of s كل هذا start. Now you find or you substitute this into this, but before I will write y من هاي المعادلة y of s star شو تساوي؟ خذ الستار لهذا السايد لهذا السايد، شو حيطلع عندي؟ هاي already هي star term، يعني بمعنى آخر I can separate it out u star g of s star اللي هو g2 of s هذا g2 of s. معنى آخر I will substitute for this u star into this equation, so I can get y star of s equals to محل هذه اللي هو حيطلع عندي، لاحظ r g1 of s star في g2 of s star over 1 plus g1 g2 h of s هذا كله مع بعض ستار، يعني y of z equals to r g1 of z، يعني بضرب الانبوت في g1 وبطلع الزي ترانسفورم، بعدين بطلع الزي ترانسفورم ل g2 of z. لاحظ هذا الترم لحاله بطلع الزي ترانسفورم separately over 1 plus هذا مظبوط times هذا بطلع لهم ايش اللي هو الزي ترانسفورم، يعني g1 g2 h of z. Now can we write a pulse transfer function? Can we write y
لأنه في الار والجي مع بعض.
أحسنت، لأنه اندمجوا صاروا مع بعض التو signals هذول. You cannot write pulse transfer function y of z over r of z. You cannot do that because r already the input and it is already combined into the block G1 to find the Z transform for the both signals. Since there's no sampler here, we could not separate the input from G1. There's no pulse transfer function for this. هلا خلصنا المحاضرة شباب، إن شاء الله المحاضرة الجاي بنكمل. شوفونا بالله انتو بقية الاثنين هدول البلوكات الموجودين. اوكي Okay, have a nice day. Okay.
العافية دكتور.